Okay, so welcome. So today I'm going to show you how we could solve a certain problem. So first, for the first page, we have the 2A. We have to evaluate 98 minus 87 plus 76 minus 65 plus 54 minus 43 plus 32 minus 21. So in this one, it's just so basic. We need to remember the PEMDAS, or the parentheses, exponents, multiplication, division, addition, and subtraction. Again, when both of that addition and subtraction is presented in the equation, we go to solve it from left to right already. Not the usual, as many know, that if addition comes first then subtraction. No. First, we need to in this case, addition and subtraction is in the same level of precedence. So, in this case, we go left to right. So, from there, we have 98 minus 87 is 11. 11 plus 76. We have 87 minus 65. We have 22 plus 54 minus 43 plus 32 minus 21. And we have 76 minus 43 plus 32 minus 21. We have 33 plus 34 minus 21. So, and we have 65 minus 21. So, 33 plus 32 is 65. And we have now the final answer, 44. We go left to right. Okay. Now, for the 2B, we have here in the figure how many square of any size can be drawn along existing lines such that the number in a square, or the sum of the numbers inside each larger square, is even. So we have here the square. It is labeled 1, 2, 3, 4, 5, 6, 7, 8, 9. If we will add, we get the sum of it as a whole. It will give you 41. And 41 is, uh, it's not even. So it's not even. So what we need to find those squares that will give us even. So first we have 1, 2, 4, 5. 1, 2, 4, 5 will give us 12. 12 is even. So we have next 2, 3, 5, 6. 2, 3, 5, 6 is equals to 16, and 16 is even. Next we have 4, 5, 7, 8. So 4, 5, 7, 8 is 24, and that is even. And we have 5, 6, 8, 9 is 28, and that will give us even. Okay, a total of, we have 4 squares in total. Okay, next. Next, we have here 74, 1974 times 6 plus 1969 times 4 plus 45 times 6 plus 50 times 4. In this case, as we have said, the rule of PEMDAS, the parenthesis, exponent, multiplication, division, addition, and subtraction. In this case, we can see the operation of multiplication and addition. So we will first do the multiplication. So we need to group them first. So you have to group them. 1974 times 6, 1969 times 4, 145 times 6, and 50 times 4. And you get the product of it. So after getting the product, we will now proceed to addition. All those operation of addition, we will now do that. That would give us a total of 20,190. So, just always remember to PEMDAS, wherein multiplication division is in the same level of precedence. If they are present on equation, you go left to right. But if one is higher than another, you go for the one who's higher. Like example, multiplication division is higher than addition and subtraction, but parentheses and exponent is higher than multiplication division, addition and subtraction. But in the case earlier, addition and subtraction is presented in equation. So what we had to do for that is we need to do left to right because they are on the same precedence. In this case, addition and multiplication is not in the same precedence. So we have multiplication first, we multiply, get the product, and then we add the product. Okay, 2D. At the corner diner, lunches have one set price and dinner have another set price. Five lunches and three dinners cost $70, and three lunches and five dinners cost $74. Determine the cost of one lunch. This is what we call solve by elimination. So each of the we need to find the lunch and dinner. So we represent it by X and Y. Okay, so at the first problem, we said there that you have five lunches and three dinners is equals to $70. That's why we have 5x plus 3y is equals to 70. And then we have another 3x plus 5y equals to 74 because we have three lunches and five dinners is equals to 74. Again, we are representing it in a variable wherein x and y will represent the cost of lunch and the cost of dinner. So here we have 5x equals to 70 and 3x plus 5yn equals to 74. Now we are looking for only for determine the cost of lunch. Our lunch is the x variable. Our dinner is the y variable. Okay. So here we have 5x plus 3y equals 70, 3x plus 5y equals 74. To be able to remove the 3y and 5y, we need to find their common multiple. 3 and 5 has a common multiple of 15. Am I right? Okay, so 3 times 3 plus 3 plus 3 plus 3 plus 3 is equals to 15. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. And for 5, you just need to 5, 10, 15. So there, to make your 3 into 15, we multiply it by 5. To make our 5 into 15, we multiply it by 3. So that is their common multiple. But then, for them to be removed, one must be negative. So, we have 5, we multiply the first equation with 5, and we multiply the second equation with negative. Now we do the equation. We do the simple algebra of using distribution property. So we distribute 5 times 5 will give us 25x, 5 times 3y will give us 15y, and 70 will give us 350. Okay. As other, we have negative 3 times 3 will give us negative 9x. Negative 3 times positive 5 will give us negative 15. So that's as you can see. Equals to negative 3 times 74 will give us negative 22. Now, in this part here, we will technically, if we will go from doing it, the 15 positive and negative 15 will give us 0. So what will remain is 95, and we combine in similar terms. Okay, we combined 95 and negative 9, it will give us 16x. Okay, 16x, and then we have 350 and negative 22 will give us 128. To be able to remove the 16 on x and let x be remained on the left side, we divide both sides with 16. By dividing both sides with 16, it would give us x is equals to 8. So the cost of the lunch is $8. If we will put 8 on our x, like 5 times x, 5 times 8 plus 3y is equal to 70. So 5 times 8 is 40. And then if we will do computation for that, it will give you the y, the value of y. Okay, so the cost of the lunch is $8. So now we will proceed to another. In the following cryptorhythm, each letter represents its own digit. Determine the greatest value of the four-digit number OUCH. So this is the cryptorhythm, or in other terms, I call it alphametic. Okay, so STUB plus TOE equals to OUCH. In this kind of problem, we just have to use numbers that will represent each letter in answering those. We will not represent digit based on like the ABCD, the whole alphabet that represent 1, 2, until 26. No, based on this equation. Okay, so STUB plus TOE. Okay, so you have your before that, we have that OUCH. Your O is in the thousand place, U is in 100 place, C is in the 10th place, and H in ones place. Okay, so it means the possible highest number is 1000. But it is just into the 4. So it means the highest possible on the fourth, on the thousand place, that would give us on an exact 4 for place of 4 is 9, because if we will go for 10, it is a 5 letter, not 4, the OUCH, but rather 4. So it means that the highest number on that S is 9. Okay, but if we go for O as 9, it means all the O is 9. So it means you have two O there, the OUCH and the TOE. The O there will represent 9. Now, in this case, we always assume that there's a plus 1, or there's a remainder 1 from the other side. So your O is 9, so we have it 9. So we always, here, we need this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the series of number that we will be checking on. Okay, so we already removed 9. So we always have to remember that there's possibility of a plus 1 that make the O as 9. So it means that S is not a bring down, because there's a different letter S and O. It means S represent different number that has a remainder 1 that gave us 9. So in that case, we can assume that RS is something that plus 1 is equals to 9. What would be that S? So that S would be 8. Okay, so it means RS now is 8. So we crash it on the other side, the 8 on our series of number. So, in that case, we already have 8. RS is 8. Okay, now next, we have here R 9 on U and O. The O is already 9. Now, on U, we need to look for a number that when we add that, it will give us the same value of U at the bottom of T plus T equals to U. Okay? The U plus O is equals to C. But we make sure that the numbers on U is equivalent to the numbers of U on the below of T plus T. Okay, in this case, we will use we have already used 9 and 8. Now we will try 7. If 7 plus 19 will give us 16. Okay, will give us 16. And if we will use 7 there, and it will give us 16, so it means RC will represent 6. Okay, if it will represent 6, your T your t now will have we need to put a certain number that will result to 16. Okay, with remember with the idea of there's a possibility of plus 1 from u to t. Okay, there's a remainder 1. So if we assume that our u is 7, it means that the t plus t is equals to there's a 7 in it, or 17, because we already carried 1 there on that 8. So it means what we have to do, if we go for that, we assume that 7 it was 6. Automatically your u plus 9 is 6, carry 1. Now your t plus t should be equivalent of 7. What would that number that would give us 17? Okay, it could be 6 plus 6 equals to 6 plus 6 is 12. 8 plus 8 is 16. Carry 1 is 17, which is possible. But we cannot use already 8 because 8 is 8 has already been used as for letter S. Now, 7 is not possible. Let's try 6. If we will use 6, if we will use 6 on our letter U, 6 plus 9 will give us 15. It means our letter C will hold the value of 15 of 5. Carry 1. So we need to make sure that our t plus t is 6. Okay. So what would that give us 16? Okay. What would that one thing that would give us the value of 6? 3 plus 3 plus 1. 3 plus 3 is 6 plus 1. No. Something that will give us 16 because there's a carry 1. So, 6 is not possible for letter U. Let's try 5. If we will use 5, 5 plus 9, 5 plus 9 is 14. Okay? 14. 5 plus 9 is 14. Carry 1. It means that your U there, if we go for 5, 15, the T plus T is equals to 15. So, what could that double number that would give us 15 with addition of 1? Which is the 7. So, 7 plus 7 with the additional of 1 will give us 15. So, there you go. If we will use 5, okay. If we will use go for 5 there, 5 plus 9 will give us 14. So it means you have also 5 there because we have the same number, letter, U. All the U now is 5. So, okay, let's go. S is 8, U is 5. So, if we will use U as 5, it means that the T and T should be equate to 15 with the idea that there's a remainder, that there's a carryover 1. So, 5 plus 9 is 14. So, there you go. C is 4. So, 14, carry 1. So, there you go. What would that number that when you add and with the carry 1 will give us 15? We have 7. So, 7 plus 7 is 14 plus the carry 1 is 15. Okay, so there you go. We have already 9, 5, 4. Now, we will now go for the remaining, the remain B and E. For B and E, we should always remember, so T is 7, so we crush out 5, we crush out 7. Okay, we crush out the 4. The 4 there is, okay, we crush out 5. Okay, so later on we will crush out the 4. Okay, now for B, what we're gonna have to do is we will try 1, 2, 3, and 6. The B plus E should not have a remainder because as we can see, the highest already number there is 14. So B plus E, the number that will not give us remainder. If we will go, 4 is already been used. So if we will go 6 plus 3, that would give us 8. and 8 has already been used. 6 plus 2 is another 6 plus 2 is 9, already been used. 6 plus 2 is 8, already been used. 6 plus 1 is 7, already been used. So 6 is not possible. Okay, now let's go for 1, 2, 3. 1 plus 2 will give us 3. Okay, 1 plus 2 will give us 3, which is less than the 4. 2 plus 3 is 5. You cannot use 5 because 5 is already been used. 1 plus 3 is equal to 4 is not possible because 4 is already been used. So, it's already assigned to a letter. So, the possibility is 1 and 2. So, it means your B is 2 and your E is, okay, is 1. So, 2 plus 1 will give us, your E is 1 equals to 3. So, that's it. Your H is equals to 3. So, okay, so all the numbers been used except for 6. So therefore, we have the greatest value of the 4-digit number OUCH is 9543. Okay? So, this cryptography is actually tricky because but then the idea here is just play with a series of 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, and then it will you can get out of it. So okay, so again we have 8, 8, 8, 8, 8, and 10. Okay, so here we have a 1,888,088. Okay, am I right? 800. No, 1,088,888. Okay, you read that as that. Okay, 1,088,888. So now for 3B. For 3B, for 3B here we have 3, 8, 13, 18, so on and so forth until we have 98. Okay, until 98. So 98 is the 20th number. If we will read the problem, if we will go read again the problem as we have it here. I will just read the problem because I wasn't able to put it there because it's kinda long. Okay, so in the problem it says in the list of numbers 3, 8, 13, 18 until 98, there are 20 numbers, and each number after the first is 5 more than the previous number. All of the numbers are added together to give a sum. What is the unit digit of the sum? So here, the 98 is the 20th number or the 20th term. So here, this is what we'll know the arithmetic series. Okay. So we in arithmetic series or the sum of the arithmetic series we follow. This is the formula for the sum of arithmetic series. S sub n is equal to n multiply or times the a sub 1 plus a sub n over 2. Now we need to declare what are those. A sub n is the last term, which is the 98. A sub 1 is the first term, which is the 3. N is the number of terms. As said on the problem, it has 20 numbers or 20 terms. So there you have it, 20 terms. Now we will apply the formula now. S sub n is equals to n. We'll multiply with a sub 1 plus a sub n over 2. Okay, now we will put already the value. So we have there, n is 20, the a sub 1 is 3, the a sub n is 98 over 2. Now we will do first the inside of the parentheses. We will first do the 3 plus 98 over 2. Okay, 3 plus 98 over 2 times 20. 3 plus 98 over 2 will give us 101 over 2 will give us 50.5 times 20, and it will give you your S sub n is 1010. Okay, so it means, so we have the unit, that is the unit digit. So that is the sum of all the from 3 to 98. 1010. Okay, now let's proceed. In the given diagram, a series of identical squares are arranged around a larger square as shown. How many total squares of any size are in the diagram using only the existing line? So we will number, as you can see, we already can see numbers there. We have the inside out that have the 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in the middle. But also as a whole, we will count that as a square. So that whole is one square. So we have a total of 14 squares. Okay. So total of 14 squares. Okay. Now let's proceed. For 4A, let's evaluate 732 minus 935 plus 865 minus 262. So, as I've said earlier, addition and subtractions in the same precedence. So, from this, we will use, or we will go it from left to right. Left to right. Okay, 732 minus 935 will give us negative 203 plus 865 will give us 662 minus 262 will give us 400. So now next we have 4VB. The three-digit counting number has each of the following properties. In this problem, it's just like we need to find the numbers and then say true. If it's true, then proceed to the next. If it's false, then we will disregard that number. Okay. With properties, the three digits are in increasing order. So the sum of the digit is 9. The number is multiple of 15. What is that number? So we have used a series of number 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, and 3. First, there, as you can see, we'll just choose three numbers that are increasing order. All of them is possible. But let's go for the next one, which is the sum of the digit is 9. 1 plus 2 plus 3 will give us 6. 2 plus 3 plus 4 will give us 9. Okay, so we have already there 2 plus 3 plus 4. Now let's try another. 3 plus 4 plus 5 will give us more than 9. Okay, and it will go for 4, 5, 6 will give us 15, 5, 6, 7 will give us more than 9. So it means that the three digits that are in increasing order is 2, 3, 4. 2, 3, 4 will equate to 9. Okay. Now, the number is multiple of 15. We need to find that number that would multiple of 15. Let's start with 2. 2, 4, 6, 8, 10, 12, 14, 16. For 4, we have 4, 8, 12, 16, 20. Now, for 3, we have 3, 6, 9, 12, 15. So, see. So, there you go. You can see that number. On the third properties, it says the number is multiple of 15. So, out of the three number that we have chosen from the first property of 2, 3, 4, and it is all equal to 9. Now that number, we need to look for, out of the three, we look for a number because this just said there, the number. It means we're looking for one number. So that number is 15. So because 3, because it is in the multiple of 15. There you go, it has multiple of 15. So what is the number? The number is 3. Okay, let's proceed. 4C. So for 4C, the number 10, 11, 12. so on until 98, 99 are written as one big digit number. 10, 11, 12, 13, 14, 9, 7, 9, 8, 9, 9. All the even digits are removed. How many remain? In this case, we need to separate it by, let's say, by level. The 10th, 20th, 10th, 20th, the 30th, 40th, and so on and so forth. So that we can see, and we can remove. So, 10 to 20, you have 21 to 30, 31 to 40, 41 to 50, 51 to 60, there, 71 to 80, 81 to 90, 91 to 99. Okay. Now, let's start 10 to 20. 10 to 20 has 15. 15 because if we will remove all the even, it will leave 15. Okay. For 21, For 21 to 30, it will leave you 6 because number 2 will be removed, 22 will be removed, 2 and 23 will be removed, and so on. 31 to 40, it will give you 14. 41 to 50 will remain 6 even digits, 6 odd digits rather. 51 to 60 will remain 14 odd. Another 61 to 70 will give you 6. For 71 to 80, it will be 14. 81 to 96, 91 to 99 is 14. Okay. As you can see it here, all the numbers are in pattern. Except for the first one because we started at 10. But if we started at 11, it will be exact 14. But as you can see, if we could say that if the numbers started even, the odd that will remain is 6 on a certain series. But if the number started odd, it has 14 remaining odd number. Okay. So the series, like the 10th series to 21 to 20, the number started with odd. So that's why it's 15. Okay? So that's why it's 15. So because it started with 1 on that series. Okay, but just an exception for that because we started at 10. But if we go for the idea of 11, it's still an even odd. But if we started an even like the 2, the 4, the 6, and the 8, all of that will give us 6 remaining odd number. Okay, but if we will start with even like the 1, 3, 5, 7, and 9, all of that will equate to the remaining odd numbers is 14. So we can now add 15, 16, 6, 14, 6, 14, 6, 14, 6, and 14. It will give us 95. So we have 95 digits remained. Okay, 4E. What is the maximum number of 3 by 3 by 2 bricks that will fit in a box that has a dimension of 13 by 8 by 4 without exceeding the dimension of the box? So let's see that this is the bigger box. This is the bigger box and this is the bricks that we have, the brick rather. Okay, so on a box like this or the dimension is measured by length, by width, and the height. Okay, so your length for the bigger box is 13, the width is 8, and the height is 4. Okay, also on the other side, we have the brick. The brick measures 3 in length, 3 in width, and 2 in your height. Now, how can we get the dimension of how many bricks can we put inside the box? First, we will divide all the length, all the width together, and the height together. So let's start with length. So your length is 13 divided by 3. So we divided by 3 without remaining. So because as per instruct and problem without exceeding dimension of the box. So it means you have still space on the box. So how many 3 do we have in 13? We have 4. because 3 times 4 will give us 12. And still we have 1. So that's one space that will remain. The 1 inch, whatever we will use here, unit. Now we have width. Your 8 divided by 2 will give us 2, because the 3 in 8 we have 6. So 3 times 2 we have 6. So we only have 2. Now for height we have 4 divided by 2 is 2. So that's it. Now for length, width, and height, we will divide the size, the length of a brick inside the box, the width of the bricks inside the box, and the height of the bricks inside the box. So we will now use the computation of using the volume. So we have volume is equals to length times width times height. So we will now use the length, the width, and the height. So 4 times 2 times 2 will give us 16. So the volume of bricks inside the bigger box is 16 bricks in total. Okay? So now let's proceed. So here, what is the value of 74 times 12 times 12? This is the same idea I have said earlier. First, we need to group them in accordance with the precedence, the multiplication, then we do the addition. So in this case, we have 74 times 12, we group them. 12 times 3, we group them. 53 times 8, we group them. 8 times 47, we group them. That will equate to 888 plus 636 plus 224 plus 376. That would equal to 2,224. Now for 5B. For 5B, Don, John, and Ron are each thinking of two-digit prime number. The numbers are different. Don's number is the least and Ron's number is the greatest. If each of their number has the total of 8, what is John's number? First, I will list all the prime number that is two digits. So it means I already jumped on the single prime number. So it is just all the two digit to satisfy the problem. 11, 13, 17, 19, 23, 28, 31, 37, 41, 43, 53, 59, 61, 71, 73, 79, 83, 89, 97. Okay, now we will go first for the least. It says here, the number are different. Don's number is the least. So the number of Don's is the least. But the two digit, when you add, it will give you 8. Okay, let's go from the left to right. 1 plus 1 is 2. That is not 8. 1 plus 3 is 4. That is not 8. 1 plus 7 is equals to 8. So 1 plus 7 is equals to 8. So that is, now we will crash. It means in the least part, we have 1, 7. That is the least. So Don's number is 17. Now the next in the problem, it states that Ron's number is the greatest. So we will start from right. 9 plus 7 isn't 8. 8 plus 9 isn't 8. 8 plus 3 is an 8. 7 plus 9 is an 8. 7 plus 3 isn't 8. 7 plus 1 will give us 8. So 7 plus 1 is equals to 8. That would be the number of Ron's. So Ron's number is 71. Now for the number of John, it should be in the middle because the two already get the lowest and the highest part. Now, we will go which of that from 19 to 61 will satisfy, that will give equate to 8. Okay, so if you will go 1 plus 9, that is 10. 2 plus 3 is 5. 2 plus 9 is 11. 3 plus 1 is 4. 3 plus 7 is 10. 4 plus 1 is 5. 4 plus 3 is 7. 5 plus 3 is 8. 5 plus 9 is 14. 6 plus 1 is 7. So there you go. We already passed where John's number will satisfy. So 5 plus 3 is equals to 8. So John's number is 53. So there. So it means in that whole series, there's only 3 digits, pair of digits that will equate to 8. So to answer what is John's number is 53. Okay? So list of prime numbers. Okay. Now for 2C, Sally leaves her house and jogs along straight road. After 1 hour, she gone 4 miles. Then Sally slowed to a brisk walk at a constant rate. After the first hour of walking in the same direction, Sally is 6.5 miles from her house. How many miles from her house will she be after 2 more hours walking? Okay, let's dissect the problem. Okay, I say dissect means we go from part to part. So here we use this formula: distance equals to rate times time. Okay, so Sally leaves her door after 1 hour. She gone 4 miles. So you already have the miles and you have the time. So now we're looking for the rate. Okay, so 4 miles equals to rate times the 1 hour. So what we're gonna do is we both divide by the 1 hour by the 1, and there you go. It will give you 4 miles per hour. So that's her rate. Her rate is 4 miles per hour. Now for the second one, then Sally slows her brisk walk at constant rate after the first hour walking in the same direction. After the first hour of walking in the same direction, Sally is 6.5 miles from her house. So it means she gone slow, where because she already used walking, not running, or jogs rather. So there you have 2.5 miles equals to the rate times 1 hour. How did I get the 2.5? Because she already has the 4 miles of running. And from there, another walk, first 1 hour walk is 6.5. So we just subtract 6.5 from 4, that will give us 2.5. It means that's her miles that she gone walking only. So from walking, she gone 2.5 miles. There, same process. We so it means that she go 2.5 miles per hour. Now, how many miles from her house will she be after 2 more hours walking? So 2 more hours walking, she has. Now we will now change the value of one, instead of 1 hour, now 2 more hours. It means there's an additional 2 hours. So distance is equal to, we already know that her per hour weight is 2.25 miles. So 2.25 miles per hour times r, technically the r will be crushed out. It will give us 4.5 miles. The 4.5 miles, again, let's go for the 4 miles will represent the first hour of jog. The 2.25 miles represent the 1 hour walk after the jog, and the 4.5 miles will represent the additional 2 hours of walking. So to answer the final question of how many miles from her house will she after 2 more hours walking, so from her house, so you have 4 miles, 2.25 miles, and 4.5 miles. That will give us 10.75 miles in distance. So that's how far she could gone from her house while jogging along straight road.